Get your free copy of the complete tutorial at www.teachucomp.com/free.
When creating tables in SQL using the create table statement, you can often set various types of constraints on the fields that are created. A constraint is a limitation that is placed upon the allowable values within a field. If a user attempts to add data to the table that violates the constraint, the data will not be added to the table. Note that while constraints are most often added to a table when the create table statement is used, you may also use the alter table statement in SQL to later add constraints to an existing table within many relational database management systems. In a later lesson, you will see that you can use the alter table statement to make changes to the structure of existing tables within a database. The core SQL syntax to apply constraints when using the create table statement is shown below. The syntax is create table, then the table name parameter, then the open parenthesis and the first field name, followed by the data type and the size parameter if needed, then the constraint name to apply to that field, then a comma, and then the series of field names, data types, and constraint parameters is repeated until all the field names for the table have been entered. Now note that the table name, field name, data type, and size parameters all serve the exact same function within this statement as they perform within the standard create table statement. The only difference here is the constraint name parameter is the name of the constraint to apply to the field. Now the following constraints are allowed in the core SQL. Not null is a constraint that you can specify to ensure that the field will not accept null values as a valid data entry. A null value occurs when no data entry is performed within a field. Note that the null value is not equal to an empty text string, a literal space character, or a zero value. Those are all known quantities. A null value is simply unknown due to a lack of data entry. Primary key fields and unique index fields cannot contain null values. However, you can also specify not null to disallow null values in other fields, regardless of whether or not the field is a primary key field or is uniquely indexed. Unique is a constraint that you can specify that ensures that all values entered into the field are unique values. There can be no repeating values within a field defined with a unique constraint. Primary key is the constraint that is specified to define a field or combination of fields within a table as being the primary key of the table. Remember that primary key fields must contain unique values and also cannot contain null values. Therefore, you can think of the primary key constraint as being a combination of the unique and not null constraints. Foreign key is the constraint that you can specify to ensure that all values within the field correspond to values found within another table's primary key field. This is used as a referential integrity check to ensure that records within a field have a corresponding or matching value within a related table. Check is a constraint that is used to specify the allowable values that can be entered into a table. For example, if you had a customer ID field defined within a create table statement, you could add check customer ID greater than 0 to the create table statement to specify that any values entered into the customer ID field must be values greater than 0. Default is a constraint that places a default value into the field specified when a record is entered. For example, if you wanted to have East Lansing appear as the default value for a city field within a table when creating the table in the create table statement, you could add default single quote East Lansing end single quote as the constraint name parameter to the city field when it's created. Note that the implementations of the SQL constraints will vary from vendor to vendor. While almost all of these constraints are universally implemented, they are implemented in slightly different ways within each relational database management system. The following hyperlinks will show how to use SQL constraints within MySQL 5.7, SQL Server 2012, and Access 2013.
Like what you see? Pick up your free copy of the complete tutorial at www.teachucomp.com/free.